Hello friends, today I'm going to solve LeetCode problem number 438. Find all anagrams in a string. So what are we given here? We are given two strings S and P, and we need to return an array with all the start indices of P such that the anagrams of P are in S. So what does anagram means? Anagram is a word or a phrase formed by rearranging all the letters or of a word without like by using all the original letters exactly once. So let me give you an example of an anagram. So suppose A B C D is a word, then the anagram would be A B D C A C D B C D A B and so on. So basically all the combinations of this word will be an anagram of this word. So now how do we solve this problem? So we are given this string S and P, and we need to find the anagrams of P in this string. So let's just see what we could do here. So we have A, B, and C. So what could be the anagram of A, B, and C? Well, it could be A, B, and C itself, or A, C, and B, or okay, I'll just use some text here. So it could be A, C, B, uh, or it could be A B C A C B B A C B C A C A B C B A. So this could be the anagrams of ABC, right? Now how do we find out the anagrams of these like if these characters, this string exist in this string or not? Basically we are looking for all of this string here in this string, so we need to check for each of these. So what we are going to do is we are going to use sliding window. So we are going to check for these three characters, and then again these three, and then again these three, and then again these three, and these three, and these three, and so on. So we are gonna check for each of we are gonna slide our window one at a time. And now we know we need to use a sliding window here. But then how are we gonna check, like if it is an anagram? We cannot just compare, we have to compare each character with each character in this string. So how could we do that? Should we check if a C exists in this string or not, B exists in this string, A exists in this string? If yes, then we are gonna add the index, the start index of these to our result. So let's just use how we would solve this problem uh, intuitively by using our human mind. So you know, like these three characters which form a single word is an anagram of this. So basically we are checking, does A exist in this? Yes. B exists? Yes. Does C exist in this? Yes. So all three characters exist here, right? So we insert a 0 here. Now what if we had something like we had one more C here? So we would have the length. So we will be checking for length 3 now, because now our window will be of size 3. So I check, does C exist here? Yes, C is here. B is in the string P. A, yeah, A is here. What about E? Does E exist here? No, E doesn't exist here. So we do not add anything, and we just move our cursor, and our window becomes this thing. Now let me just clear this thing up. Now our window is BAEB. So this is our window. Now we'll check, does B exist? Yes, B does exist. What about A? A also exists. E doesn't exist. So we again shift our window and this becomes our window. We know again this window also consists of E, so we just shift our window again, and again it consists of E, so we shift our window again, and now we have BABA. Now let's check here, does B exist in the string? Yes, it does. What about A also exists. B again, B also exists. What about A again? Yeah, it does exist. But now the problem with this is that our window has two characters repeating. B is repeated twice and A is repeated twice, but we only have one A and one B here, and we have two C's here. Do we have C's in this? No, we should have two C here. So just checking character by character is not enough. We need to have to keep account of the frequency of the characters in this word and in this word. So basically what are we checking is, oops, sorry, I need to erase this just to make it a little more clean. Okay, so basically what we need to check is, we need to check, does every character occur the same number of times in each of the window here. So we have to match the frequency and the character. So the character plus the frequency. And what is the way to store the frequency of each of the character? Where that's map. So definitely we are going to use a map. Now how are we going to check about go about checking if the characters exist in the map or not? Well, what are we going to do is, we create a map, and then for each of the character A we have the frequency 1, for B we set the frequency 1, for C we set the frequency to 1. So basically A, B and C, they occur one at once, so each of them have the frequency 1. Now we go to our origin, our string S, and we set our window from for this size, then the size is equals to the size of P, and we check, does C exist in the map? Yes. And what about the frequency? The frequency is greater than equals to 1, so cool. We decrease the frequency of this by 1, and then we move on to the next character. Does B exist in the map? Right, it does exist. And what about the frequency? Is it greater than or equals to 1? Yes, it is greater than or equals to 1. Sorry, this should actually be equals to 0. So we update every time we subtract the frequency by 1, and then the result here for B is 0 and for C is 0. Next we move on with C. So does C exist in the map? Yes, and the frequency is greater than equals to 1, so we update it by subtracting it by 1, and then we get the result equals to 0. Now we also need to keep a counter C. So initially C is equals to 0. Now each time our condition is fulfilled, that is each time the map has the character and the index, the frequency is greater than or equals to 1, then we increase our counter. So when we encounter C, we increase our counter by 1. When we encountered B, we increased our counter by 1 again. When we encountered A, we increased our counter by 1. So the counter value here is equals to 3. And 3 is equals to the length of P, which is equals to the length of P. So since this is equals to length of P, that is when we push the starting index of our sliding window of our window. So I push the window 0, start index, which is 0. Now we have done for this. Now we start from our loop from I equals to 1. So for starting from I equals to 1 to the length of the s, we check. Actually it should be I equals to 1 to I equals to this value, because we should have at the end the sliding window should be of length p. So if it is that, then the I should end at s dot length of s minus length of p and plus 1. So this would end us here at this position. So this will be our so we will go through iterate from I equals to 1 to this value. And now what we are doing, we are actually shifting our window. So my window will be this. So what am I doing right now? Initially my window was this CBA. Now my window is BAE. So I'm actually removing C from my window and adding E to my window. So when I remove C, I actually need to update two things. One thing is I need to update my map, because map my window only has BAE. So I remove C from my window and then I update my C. So now my C is equals updated to 1. From 0 I add plus 1 and it is updated to 1. And then my E, does E exist in the map? It does not exist in the map. Okay, one more thing. So when I update my C, when I remove my C from the window, I update my C by adding 1 to the 0, and then I also update my C by subtracting 1 from my counter. So I subtract 1 from my counter, so now my counter is equals to 2. And then for this window, for the window of BAE, now I removed C. Now I need to add E. Right now I check in my map, does my map has E? It doesn't have. So it doesn't have E, which means that I'm not gonna update my counter here. So my counter is only equals to 2 right now. And then at the end I check, at the end of the for loop, within the for loop I check if the counter equals to 3. No, it is not. 3 is actually the size of P, so it's not equals to 3, which means that it is not an anagram. Next I move to my another window which is of size A, which consists of AEB. So actually I am removing B and I'm adding B. So while I remove B, I update my value of B by adding 1, and then I also update my counter, because now I'm removing B and B was in the map. So I update my counter by subtracting 1. So my counter is equals to 1 right now. And then I updated B. I only have this much. Now I'm adding B to my window. So when I add B to my window again, I again update my map by subtracting 1 from B, and then I update my counter by adding 1 to the counter. Still the counter value is only 2, and 2 is not equals to p dot length. So I move to the next window. So my window is now EBA, and at this point also now I am removing A from the window, so I add 1 to the window. Let me just clean this up. So what's my window now? My window is now EBA. Initially I had A in the window. My initial window was, before that my previous window was AEB. Now what I'm doing here is I remove a, so now my window only has EB. So once I remove a, I updated the value of a by adding 1, and then now I'm adding a to the window again. Um so when I add a to the window, now my window is EBA, and at that time, okay, while removing, I also need to subtract 1 from the counter, so the counter value is becomes equals to 1. And after adding a, I also update the value of a by removing by subtracting 1, and then I also update my counter by 1. So now my counter is equals to 2, and again 2 is not equals to the size of p, and we can see by intuition by that EBA is not an anagram of ABC, because we need a C here. Again our counter becomes BAB, our window becomes BAB here. Now what happens here? When my window is BAB, my previous window was EBA, so I removed E from here. Was E in the map? No. So E was not in the map, but still E was not in the map, but still I'm gonna subtract from the counter -1. So my counter is equals to 1 now, and then okay, my bad. So I do not do anything here. I do not do anything there, right? It's not in the map, so I don't do anything with the counter. I do not change the counter, and the map won't change. The counter doesn't change because it's not in the map. Now I add B in my to my window. So B has map has B, right? So I update my map value by subtracting 1 from B. So now the value of B is -1. So I do not update the counter. Also, why? Because you could just see B is occurring twice, and in my original in the string P, I only have A and B, and here in the map you could also see like I had 0 0 and 1. So I actually needed a C. I don't need a B in my window. I already have B and A, and since now B is -1, I do not increment my counter, so my counter is still equals to 2. And then I again shift my window. Now my window is ABA, and I add a 1 to B. So now my map has B is equals to 1, and I'm adding an A here. So now my A is equals to -1, and then I do not again update my counter because this value is negative here, so I don't update my counter, and the counter is still again equals to 2 only. Now again I change my window, and now my window is BAC. I'll just change the color. Now my window is BA and C here. This becomes my window. So I removed an A, so I update the value of map here by adding 1, and then I am adding a C also. So I remove subtracted by 1, and it becomes equals to 0 by adding 1. Actually I'm adding 1, so it becomes equals to 0. I'm adding 1 to -1, so it becomes 0. I'm sorry about this calculation. So 0 0 0, so it becomes 0. And now since it is equals to 0, then which is a positive value, then I update my counter, and my counter now becomes equals to 3. And is 3 equals to the size? Yes, it is equals to size of P. Then I update my result by adding the in the point where the slide begins, the index of where the slide begins, which is equals to 6 here. 0 1 2 4 5 6, so which is equals to 6 here. So I add it to my window, and then I do the same for my last one. So I remove b from my window, so I increment it by 1. I added d is not in the map, so I do not increment the counter. And when I removed b, I also had to subtract -1, so counter equals to 2. And then on addition of d, I do not change the map nor do I change the counter, so counter is still equals to 2. So my final result is 0, 6. So let's dive into the code now. So we need a map for let of p if map already has c. So now here I created my map. Now I need to start to check if the anagram exists in this one or not. So first of all, I'll just do my initial check of length equals to p. So let I equals to 0, I is less than p dot length I plus plus. If map has si, okay, let me just use c equals to si, so that it becomes easier. So if the map has the character c and the value of map, the frequency is greater than 0, then what I'll do is, okay, it should not go here. Actually, if it has, then I'm always changing the map, right? I'm always updating here. You could see if the map has it, if the map has the character, I'm always subtracting 1 from each of one from the value. That is why I also got a value -1. So if the map has it, then map dot set, we are just going to update it. Map dot get c -1. Okay, I need to see here map, so I'm updating it by subtracting it. And then if only map dot get value, so I'm only changing the counter only if the value was positive, right? So I only changed the counter when the value was positive. I did not change when the value was negative, that is -1, because here in case of BAB, the value of b went to -1, and we know that b only the maximum number, so the b and BAB, only b, 1b and 1a exist in the string p, right? So the counter is only equals to 2, and then that is why we do not increment the counter if the value of the map is negative. So if map is less than 0, actually greater than equals to 0, then count plus, okay, I need to define count equals to 0, then count, then only we increment our count. Else if it doesn't have anything, then we are not going to do anything. If the character doesn't exist, we just don't do anything at all. Now we check if count equals to p dot length, then I need a result array, and then I'm gonna push 0, because right now my index is starting from 0, right? And this is my whole window from 0 to the length. Now what I'm gonna do is I equals equals to, now I'm starting from ith index and then moving on to the character C, leaving the window size so that I have the last window size equals to 3. So starting from I equals to 1, I is less than as the length minus p the length, because I need to make one more last window, because the window could not be less than the size of p, so that is why. And then increment my I every single time. And now here I'm gonna check if map, okay, I'll just put this thing here, so okay, let it be there itself. So what I'm gonna do here is I'm gonna do the similar thing. Map dot has gonna check, does the map have C equals to si, does the map has the character C? If it does, then I'm gonna set C from my map dot get character C minus 1, so we are subtracting from the character, and then changing the count. If the count is greater than or equals to 0, if the count is positive, then we increment the count, else if the map so this is for the for adding a character, right? So when we add a character to our window, that is when we subtract 1, and when we remove the character from window, we need to do stuffs for that as well, right? We need to update the map and the count as well. So when we remove, the character would be at position so when I'm at position I minus 1, so initially my window here for this for loop, my window here is from 0 to p, that length which is from 0 to a. Now my window becomes BAE. So I starting from 1, I'm actually removing the character at index 0, which is I minus 1. So that is what I'm doing here. And now if map has that character, only then we need to change our map +1. So I updated my map, and then if only map dot get C is so if only map was positive, because we only changed our counter, incremented our counter when the value of C was positive. So we're only gonna decrement our counter when the value of C is positive. Value of C is greater than equals to 0. Okay, actually I did something wrong here. So here I am removing character from the previous window, and here actually I need to add character to my window, right? So what I am adding, my previous window was this, now my current window is this. So I already have PE, I am actually adding only the last character, right? So this I should be, it should be something else. So what would it be? It would actually be I plus the length of this minus 1. So I plus length -1. So this will give me the index of E, and I'll add that index here. So we actually need to remove first before adding to our window. So I'm shifting my window, so I remove C first and then add E to my window after that. If not, then we will actually go to the problem. That will create some problem. So I'm removing the character. While I remove, I decrement the count and I actually increment the map. And then while I add, I decrement the value in the map and I increment the count. And every time I do that, I again check if count is equals to the length, then I push the value I, because I is the start of the window, the sliding window, and then I finally return my result. And let's run our code. Okay, something is wrong. All right, I'm using C here. I should be using S of K. Okay, so these are all the small mistakes that I keep making. Maybe that would create problem for you as well. I'm sorry about that. I'll try not to do such mistakes in the future. Great. So we could now see, let's try some other test cases. What about A, B, B, A, and then we have A, B, A. What about only a single character? Let's run our code again. Let's submit it now. Okay, so what would be the time complexity and the space complexity? Well, space complexity is we are using one map and an array, so space complexity is O of n, and the time complexity would be we are use this is of O of, if the length of P is m and the length of S is n, then this is O of m time complexity. And here this is also of m time complexity, and this is we are going from I equals to 1 to the length of S, right? So this is O of n time complexity. So the time complexity is big O of n plus m, and space complexity is big O of m. Okay, have a great day, guys.